Okay. Friday, when we finished up, we were talking about systems, and we had graphed one by hand, and then we had plugged in values for x and come up with y1s and y2s by hand, and we probably even graphed it on the calculator. Today I want to pick up with the two special cases. One of them is when the lines are actually the same. They may be disguised. You may not realize it right at first, but they are actually the same line. And if they're the same line, how many solutions are you going to have? Look back on page 72 on your notes. If they're the same line, they're laying on top of each other, so you're going to have all the same results, or all the same solutions. You have an infinite number of solutions. What about if they're parallel? How many times do they touch?
Never.
Never. So how many solutions do they have? Empty set. No solutions. Okay, so that's what we're going to see graphically right now with the two special cases. The first one, we always need to put our equations in slope-intercept form first so that we can put them in the calculator to graph them and solve them graphically. What about these two equations here on number 3? The first one is in slope-intercept form, correct? Y equals 1/2 x minus 3/2. What about the second one? That one's kind of crazy looking, right?
Yes.
Okay, well, if you remember back from fractions in either 7th or 8th grade, if everything is drawn over one denominator, then you can break that apart and, in this case, make two different terms out of it. So this one would be y equals 2/4 x minus, and then you would take this term and that minus sign, minus 6/4. What does that reduce to? Y equals 1/2 x minus 3/2. Now look at this one and compare it to the one up here. What can you tell me? They're the same. So when we graph that, we expect to see how many lines pop up on our calculator. 1, because one's right over the other. Okay, let's do that and see what happens. Okay, follow along with me with your calculator. Hopefully you can see this, or somehow. Okay, so what we've got is, and I'm going to put it into the calculator just like it started, because you can do that. As long as it says y equals, you can put it in the calculator. I'll show you why. You just got to watch out for parentheses. Always use your parentheses with anything fractional. So y equals, make sure it's cleared out. And for the first one, I'm going to put 1/2 x. I'm going to open my parentheses. So you do the same. So it's open parentheses, 1 divided by 2. Close your parentheses, because that's the number in front of the x. Okay, the x goes outside the parentheses. Then put your x. Okay. Now, minus sign. And then your 3/2, put that in parentheses too. 3 divided by 2. Now, it may work, and it probably will work if you don't use those parentheses, but get in the habit of using them, and that way you will avoid a lot of calculation mistakes. That keeps your order of operations intact. Okay, so there's the first one. Now, on the second one, I'm going to put it in exactly the way it looks here without dividing it into two different terms. So I'm going to open my parentheses, and I'm going to put 2x minus 6, and I'm going to close parentheses. And all that is divided by 4 in my fraction. So divide by 4, and I'm ready to graph. Does yours look like this on the calculator? Okay. Now, when I hit the graph button, I only expect to see one line. Yes? Okay, go into your window and make sure that your mins and maxes, your minimum should be negative 10. Your maximum should be 10. So x min should be negative 10. X max should be 10. Okay, and your scale is 1. All right, so I'm going to hit graph, and I hope to see one line. There's one. Let's see if it draws another. Okay, I only got one line. So what are my solutions? Infinite number of solutions because they're laying on the same line. One, they're touching at every point they can possibly touch. Okay, so in this type of situation, when you get one line, it's the graph of the same line, so your solutions are infinite number. Okay, and that's how you'll answer that. Any questions about that one? Okay, let's look at number 4. That's the other special case, and that is when they have no solutions in common. So we have an empty set of solutions. And what can you tell me about lines that have the same slope but different y-intercepts? Now think about the same slope. Okay, lines that have the same slope, put this in your notes somewhere. Are always parallel. If they're parallel, they'll never touch each other, correct? So we have no solutions when our slopes are the same. Now, could you look at these two equations and just right off the bat tell me their slopes were the same? Probably not, okay? Well, we could break them apart by hand into y equals mx plus b. Or since they both say y equals, why don't we just put them in the calculator and see what happens? If you use your parentheses correctly, you can get both of these equations into the calculator and get the graph. So here's what I'm going to do. Move it over just a little bit. Clear out your y equals. So clear, clear. And let's enter those in. Be sure to use your parentheses and you'll be fine. So the first one says y equals x plus 3 divided by 2. So I'm going to use my parentheses. X plus 3, close my parentheses, divided by 2. That's my first equation. What is my second equation? How am I going to put it in?
2x over 4?
Yep, open parentheses, 2x, well, let's say 2x minus 3. Okay, and then divide by 4. Okay, check to make sure you've got everything the way you want it. And now let's hit graph and see what we get. Okay, we have two parallel lines. They're never going to touch, no matter how far out we draw them. So we have an empty set of solutions, or no solution. Okay? Now, just for fun, let's rearrange these by hand. So you can see that slope is the same. Okay, you've got something wrong in your y equals. There's probably a minus sign that's the wrong kind of minus sign. Okay. All right, let's go ahead and rearrange this. This is actually the same thing as saying 1 over 2 times x minus, or is that plus? Plus 3 over 2. And this one is the same thing as saying 2 over 4 times x minus 3/4. Now, look at the slopes. Look at the m term. What's this one? 1/2. What's this one? Which is 1/2. So they have the same slope. So if you did take these and do that first by hand, you'd see that the slopes were the same. And you know to expect some parallel lines. Okay. So when we have parallel lines, we say we have an empty set for our solution. They don't touch at any point. Are there any questions over those two special cases? If not, let's flip over. We have several problems to practice with on